company is.
Yep. So I'm Keith Bradley. I'm the VP of IT and Security for Nature Fresh Farms. What we are at the core is we are a 250 acre greenhouse growing bell peppers, tomatoes, cucumbers, and strawberries. This is all enclosed in glass, so there's no outside environment other than the light that we want to come in going to the plants. So it's basically we basically take complete computerized control of the life cycle of the plant. And so what we've strived to do is to grow more and more peppers, more and more strawberries per meter squared, and increase that yield every year. So what we did is we started off 20 years ago, 23 years ago now, with a 16 acre greenhouse. And our owner wanted to be data forward, even at that time. And there wasn't, at that time, it was weird to say one computer ran the greenhouse. So even back then, we had one computer running the greenhouse, opening the vents, doing stuff like that. Fast forward to about 8 years ago, we started to get to the point where we said, we need more power. And we need to start to take the data that we've collected and make it usable and change the way we do things and turn our greenhouse from a reactive state to a proactive state. We want to change the greenhouse before the weather hits. We want to be at the right state to make that plant grow optimally. And that's what we do every day.
And that's what I mean by the reality of AI. We're talking about plants in a greenhouse.
Yep.
We're talking about optimizing yield, real financial impact for a business, and not the stereotype of, I don't know, ChatGPT inventing answers to questions or something,
Yep.
right? So tell us a little bit more about the technology.
So, yeah, how many models are we talking about, Keith, in your
We probably have about 32 models that run at different times.
32
Yeah.
different models
Different types of models, different plants.
for different
Yeah.
aspects of the farm,
Yeah.
I'll say. Right?
Yeah. And it was actually neat because it was neat to go back on our journey to see how it was, because seeing the slides earlier from Intel, it really hit home with me of how we kind of hit on it. As we started off with a 3-core cluster, just it was actually a Gen 2 Xeon, and we had problems with it. We couldn't quite get the compute that we needed. So the quickest thing for us to do was to add more compute to it. So we added 2 more nodes, and we seen better performance. We didn't get what we wanted, but then we updated to the Gen 3 now, and we've actually seen a huge performance increase. So it was kind of neat how we kept it all in one system, but we got the different generations working to help us build each model language.
And I'm assuming you got sensors throughout the farm taking all this data input, moisture, growth, maybe some vision cameras and stuff like that. All these are feeding these 32 models.
Yeah, yeah. It all feeds into our core data center. It starts at the edge and then it feeds in each night. Well, about every hour or so, it syncs up the data. So you got to think about and when you record data, you got to think we not only record how much light they're getting, how much light we artificially give them, how much CO2 we inject from our natural gas generators to help them grow, the irrigation level of the plants that go in, how much nutrients that plant didn't accept. In the past, we've even weighed a tomato vine in real time to guess its weight. All that information comes into our core so that we can see and basically optimize the growth of that plant and react to it. So it's one of those things that we just continue to grow each time. Like if there's a sensor out to do it, we're recording it. And we are constantly looking at new ways to understand what that plant does.
I didn't see vision stuff. Are you doing a lot with vision?
Yeah, we do have vision going down the rows. So we have robots that do go down. We partner with a lot of companies that do it too, and they use our infrastructure to do things. The best example is that we've had ones to do harvesting. We've had ones to do bioscouting. And we keep looking at different ways to do it. Robotics in the greenhouse, it's a harsh environment. It's a hard environment to be in. So it's not something that is really robotically ready. It's not like a factory. It's very different. So robotics in the greenhouse, I think, is still a couple years away from really doing it.
It seemed to me that these 32 miles would be useful for any farm or any greenhouse, at least.
They are. Yep. It's all the basic technology.
Are you providing a managed service for this stuff, or?
No, we haven't done it. We're still a sole proprietary. We're trying to get to that part. but we do invest a lot into our R&D section to help improve how we do things internally, and we do share it out with our growers that we purchase products from to help them improve their model. I like to say one day, and I see where you're going with this, I like to say one day, you know, you have software as a service, one day we'll be a farm as a service.
Yeah.
And we'll be selling something out to people to say, here's this to help make you grow better.
And I'm thinking on Mars.
Yeah.
Right? So I know that wasn't probably your intent.
Wasn't mine.
But you know, if
Space.
we're going to sustain humans in really harsh environments, it's probably going to utilize all that stuff, no matter where the harsh.
You're going to need
environment is.
potato models.
Yeah.
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 And that's it. It's because
Potatoes. Yeah. On
Yeah.
Mars.
we actually do. We control every aspect of that plant's life.
Yeah.
It doesn't get it gets no moisture from the outside. We control all that. The only thing that we let in is the sun. And as I showed somebody earlier today, even on a day like today in Leamington, Ontario, where the sun is out, but it's not great, we will supplement it with lights to make sure that that plant optimally grows all day.
What about pests? Like what kind of, I know it can't be a completely sterile environment, but like, or is it? And you have to worry about pests? And...
It is. It's pests. And it's actually something that we've dabbled with and we're still dabbling with and how to do it is to actually have a robot going down the rows and not looking for the bugs.
Oh.
Yeah, we don't, because we actually tried that. Let's go find the bugs, but it's like looking for that spider in your house that you seen there 5 minutes ago. It's gone. You'll never find it again.
And tomato wormworms are hard
Yeah.
to anyway.
Yeah. So they're all over the place. So what we did is we actually kind of reversed our logic and used more of the model languages to say, let's look at do the leaves wilt?
Yeah.
Does it not take as much moisture? Is it not doing what it normally does? And basically started to teach the model. We partnered with another company to learn has this infestation. And so we started to learn that way.
That's
So
cool.
yeah, we actually went so far as I know we trialed it and we're still learning and we continue to learn every day about it because AI is new. For everything, we actually went and infected an area. We actually purposely infected to learn how that happened. So it is something that happens. And then what we do to fight back, and my dream of this, once we get this figured out, is we don't use pesticides in the same way an outside greenhouse do. We actually use other biologicals. So aphids will release a ladybug.
Nice.
That doesn't affect the environment, and they'll just eat those aphids, and then there's nothing left.
That's what I do.
Yeah. Everyone wants to do it as best as possible. So that's how we kind of control it. And it makes it a much more controlled environment in that sense. We always have pest pressure. There's never going to be an end of it, but it's something that is there.
What does the team look like? Are you using mainly off-the-shelf models, or is it like highly proprietary that you've trained? Is it outsourced in-house?
Mostly in-house. A lot of vendors have helped us out. We've had other vendors, mostly from Europe, provide us with some models that help us learn, help us as a base point. A lot of times, what I like to say is that we've gained a lot of knowledge because we have the infrastructure to handle things. We're one of the few greenhouses that are aforementioned in going for a large infrastructure. We have the compute, we have the storage, so we don't have to go to the cloud because most farms in our industry don't have an internet connection that can handle any cloud type of resource. So we have to be on-prem. We have to compute on-prem or it won't work for us because it's only been in our area, we've had fiber optics. We just got it for residential last year. So in our area, and we've had fiber only for the past 5 years in Nature Fresh. So you can't rely on cloud.
So, I'm sorry, Keith, talk to us about the hero numbers because we're literally in the weeds.
Yeah.
Talk to us about the hero numbers from either a business return, environmental, et cetera. What has deploying these models helped you achieve from basically a headline perspective?
Yeah. So one of the big things that it did for us is every year we want to see an increase in yield. We measure everything by per meter squared. And with the technology and the modeling that we do, we are seeing a good trend at a 3 or 4 increase per year. So think about it, the same plant is growing more product for the same space. And we're only using the same amount of resources. So with modeling language and how we do our compute and AI system, we lose about 1% of the water that we feed to the plants. So if I give a water 100 liters, if I send out 100 liters of water and we get back 40 liters back from the plant, we measure it, we understand it, we sterilize it, we get it back to a point, and then we put it right back into the system again. So that way it's a total closed loop. So we're not wasting water. Same with natural gas. We burn natural gas to heat our greenhouse. We take the runoff of natural gas for CO2 to help stimulate the plants at a natural growth rate. And we've seen substantial benefits of that in the yield every year, so much that when we don't run natural gas, and it was something that we learned through our modeling, we'll actually inject them with a liquid CO2 to help keep that stimulation going, because we didn't realize that was there.
So I have a question. Couple questions. Number one, I'd like to know more about your team, the
Yep.
size of them, what they do. But number two, a lot of the things you're saying are gardening knowledge. It's kind of like,
Yeah.
if you're a gardener, this is the stuff you learn over years of experience. So these models that you're building out, are they influenced by a farmer, or like, is there, are y'all just getting scientific stuff and trying it out because you have a big old
Nope.
thing to play with?
Yeah. So our growers are key to our knowledge of what it is, because they're the ones that have that years of experience in the plants and know what's happening. And so they help drive what's actually happening, helping us to understand, okay, helping the AI and the model languages to understand what's happening, what's really happening, because sometimes it's new. But the nice thing about it is a grower's knowledge is only good usually for that one silo.
Yeah.
And now it's not siloed. It's actually going to be for our entire acreages. So we have a facility in Leamington, Ontario, multiple facilities where growers won't see each other for weeks. But once that data is in the system and that model is there, it'll now know how to react properly now.
Right. And what is your team? So you're the IT. You said
And the VP of IT. So
what do your teams look like that are actually making this all work?
yeah, so I have a DevOps team. It's a small team, about 3 people that really work with the growers and work and understand of what's going on. And the model doesn't just start at the plants, it actually goes right through to the warehouse, to packing, shipping, and everything like that. We always focus a lot on the growing, and it's something that's neat to see, but we do take the compute and the power right from the growing to the time it hits a truck, goes out to a customer like you.
Yeah, because I imagine the strawberries I get in Texas from down in Ontario, well, in the middle of the winter where there's no strawberries,
Yeah.
y'all don't pick them right. Or like, is that kind of go?
Nope,
to
we picked them all red.
You pick them ripe, and then they get to Texas and they're still okay.
I'm gonna say we won't make it to Texas. That's what we're trying to do. That's what we've done, is we distribute our greenhouses near distribution centers.
Okay.
Where do we get them so that we can get that tomato that we picked, that strawberry picked from our farm to your farm in about a day or two, 2 days at the very most. That way it's as fresh as possible.
And so I guess the models are also, because that's also a thing too, knowing when to pick pick the tomatoes so that it's ready to put on a sandwich right away. Or
yeah, and that's the next thing that we get into with our modeling languages, is our yield forecasting. Because what it does is we're 2 companies. We're a farm growing, and then we're a sales company. And so what it does is it helps give us an accurate forecast for what the sales needs to sell. So that they're not overselling, but they're actually knowing this is about what I'm going to have to sell, because if I don't, I got to find more people. And we forecast, and like any forecast, I'd like to say we're better than the weatherman, but some days I feel like we're not. The farther away it is, the harder it is to predict. But when we get closer, we know pretty accurately how many boxes of strawberries we're going to pick, how many clamshells, how much weight and TOV we're going to do, and what numbers even are. Are they grade 1, grade 2, grade 3? So we can start to say, where do we find these sellers so it doesn't go to waste? It doesn't just get thrown out. And that's one of the key things we like to do.
So I'm sorry, go ahead.
Yeah, so you have several farms then? It's not just the one in Ontario?
So it's one in Ontario and one in Delta, Ohio. So we're divided into phases, usually ranging from 15 acres to 32 acres.
And where does your IT teams and your DevOps teams sit?
And we're all in Canada.
Okay.
Yeah.
And so that's all.
So how often do you train the models? Every harvest or?
So we usually do it almost pretty well. I'd like to say we're kind of retraining. I'd say every harvest is a fair way to do it, but we update it almost monthly. It depends on the time of the season too, and how
Okay,
much.
so if it's active growing or something like that,
Yeah.
you update it more frequently.
Yeah,
and stuff
because
like that.
the biggest variable that we've learned too that it changes is the outside weather. We control it, but there still are influences over energy and stuff like that consumption. So we kind of have to update and change the way we're looking
And so
at
the
it.
models are actually feeding irrigation valves and
Yeah.
CO2 valves and things like, so they're actually driving IoT devices
Yep.
to turn things on and turn
Yep.
off
Yeah, so like even,
during the day and stuff like that?
even like that, even something as simple as, okay, in the summer, it's too warm in the greenhouse. Which side vent do I open up with the wind blowing the hot air in, or do I open up the other side so it just lets the heat out? And like things like that is what it looks at in the
So
analyze.
you're taking external data about weather and stuff like that, as well as
Yep.
as your own sensor input and stuff
Yep,
like that.
every greenhouse actually has basically a live weather station to help react to it, because we have to know.
Yeah, yeah.
Because the best example, it's always funny, and I love to see it. It's always funny every time we show a video. The peppers and tomatoes are always wet. And it just it makes the video look great, and it's just a neat thing. But we never water our plants that way. Like it doesn't exist. We actually don't like it because that's an uncontrolled variable. We close the vents before the rain hits. We want that closed, so that way that radar is watching for that rain to come and turning and closing those vents beforehand, and then predicting when it's going to open it back up depending on what it needs. Because we also monitor the humidity. Is the humidity too high? We also have energy curtains, we like to call them. So they're curtains that open and close within the greenhouse to either block the sun or to hold the heat in the winter, so it can protect them.
So Keith, we haven't really touched on the actual infrastructure much. I know we've talked beforehand. You have sensors on every tomato plant. These plants kick off, 25 gigabytes of data a month per plant. I'm thinking your compute infrastructure is what, about 50, 60 nodes? What does it look like?
No, we're at our core. We are 7 nodes, 2 of which are a dual 4th gen Xeon processor that we've just upgraded to, and we're just getting to that point. So we just run constantly. So we're not doing that, but that started our journey because we started off with less CPU power, and we just kept adding ways to do it, and we grew. And seeing the models from Intel earlier made it really hit point that we just kept growing, and it just kind of kept that processing when we need it.
So what does the deployment of the infrastructure look like in terms of the applications? Because obviously you're driving everything end to end in these, so I imagine an outage of IT infrastructure would be catastrophic.
Yeah.
So what does the deployment model look like? You're using Kubernetes, and that's how you're leveraging the CPUs, or is it just a standard kind of monolithic application, or what does that look like?
We're slowly transitioning to Kubernetes now. The old model didn't quite, it was more of a homegrown model. It's been slowly transitioning now, but we are doing, but all the data just flows in through our network. We have a large store that kind of, an S3 bucket that stores strings, JSONs that kind of inference everything and keep things coming in and understanding where they are. And then each edge has that. So hopefully that's kind of gives you an idea of what we're doing. So we'll have an edge in 1 acre, say 32 acre range doing the local compute, then pushing it over there as it can during the day.
Can you talk more through the start of your journey? You said you started 3 nodes. Like, what was the business motivation to start? Where did that come from? What were the early wins that helped convince you to keep going?
So I'll be selfish. The first 3 nodes wasn't even really with the concept of AI. It was just more because I wanted to get to a point where I could have a robust system that could stay up. I wanted to switch from a converged infrastructure to a hyper-converged that could take downtime, understand we could do updates during the week, and have VMs be able to shuffle very seamlessly. Our VX Rails system that we started with 3 nodes worked for us really good, but like I said, that's where we started. We maxed it out within the first year, so we had to add 2 more nodes. And now just in the last year, we added 2 more, even more higher end CPUs to help that workload. And it's funny because each time we add the nodes, I usually will get a big thank you from a lot of our areas because we see a direct reduction. So one of the ETLs that we run, and it's more of a database ETL that we run on our labor side, that really compares how the labor is working and how efficiently they are. it would take 3 hours to run. It's now down with our latest generation down to 30 minutes. So now even us, we're trying to optimize our labor. Now we can do that multiple times a day instead of twice a day.
What does the storage look like? You mentioned S3 back then. Is that a self-hosted S3 solution? And,
Yep.
and what does your data retention look like? Because I imagine if you're capturing, Keith mentioned 25 gig a day per plant, I imagine you've got quite a few plants. How far back can you go, and do you utilize that old data to help enhance future models?
Yep. So a lot of the data is transactional. We just kind of, it does something that moment and gets rid of the data. So it goes in and out very quickly. Some data stays an hour, next data can stay there. But a lot of our key data, like growing information, temperature, yield, things like that, we have that going back for 8 to 10 years. So any weather-driven stuff, we'll keep that for as long as we can. It's all stored in our system. We have roughly about 250 terabytes of active memory that we use. There's another 250 terabytes that's a little more offline storage that we do kind of hold long-term data, but we don't actively use it that way.
And what is is it like a time series database, or is it just a normal transactional database? Like, how are you storing that data?
It's a transactional database. Yeah, it just literally flows in and out, and then it filters out what we don't want to keep and stuff like that, and just deletes itself. Like one of the areas that we do a lot of inferencing with pictures is on the packing lines. So one packing line that we have, you get a box of tomatoes that comes by you. What I see as red, what you see as red, what you see as red is different. It'll actually tell you through the vision system saying, take that one, and that one out and put these ones in place. Because that way they're all the same red. There's multiple things that we got out of doing that we never realized, is it also increases the shelf life of that box. Because now all the tomatoes in that box are the same age, same ripeness, same everything. So it helps increase yield. You don't got one tomato, because everybody's done it in a strawberry container, blueberry container, where you have one bad one that ruins 10 ones around it. So those are the type of things. And then even as far in the packing line area, we don't let the employees pick what's a grade A and grade B. The AI vision actually looks at the tomato, takes pictures of it as it's rolling, and decides which chute it should go down for that person to load it.
Cool.
So that way it is done as efficiently as possible. So they're basically just counting it up, even to the point where we played with it and it's changed, where they put the box on a scale, and it's an IoT scale that weighs that box so we can see it. So we know that that box meets our plus and minus that we want it to be to go ship out. Yeah.
First of all, congratulations on this, because it sounds awesome.
Thank you. And I got to tell you guys too, Lori, I have been amazed at the intelligence in here. It's just amazing, the AI, because I'm like, I thought I had a good knowledge of it, but talking to you guys last night, no, I gotta go back to school again one more time.
Well, so based on that comment, then I have a question about your environment and what you do and your business. What level of maturity? There's a lot of inputs, a lot of feedback, a lot of data that's coming through. How would you rank your maturity within your organization, and how much automation are you using versus manual process to get to that point?
So I'd say it's twofold. So automation within the greenhouse is still very premature yet. We can't quite get it there. Automation within the packing level side is very advanced. So that's where we really focus a lot, is that. And then I figure 5 to 10 years yet for the greenhouse side to really catch up. I had somebody ask me that, like, where were they in scales? And I'm like, labor in the greenhouse is still a very manual process.
And is that is that your vision where you want to get to? Or?
I see eventually, like, we've actually invested to have more robots to pick. And what we're looking at doing is, how do we get to this point where the robot can pick it better than a picker, but at the same cost efficiency? It's just, robots aren't cheap. And unfortunately, there are certain human elements that we can't beat for speed.
So from a data perspective,
Yeah.
And I know you have that kind of bifurcated approach you were just talking about, what would you say from a percentage for automation in your overall organization?
I'd like to say that we are probably 10 to 15% automated within the greenhouse. With probably in the warehouse side, we're probably more at 60, 70, 80, right in that range. One of the automation areas that we do have that does tie back, and it is neat, it's neat to watch if you ever come into a greenhouse, is a lot of our systems use an algorithm and an AI to basically say where the scales go. So we have automatic driving carts that take carts to the employees as they need them and to pick them up after they've picked.
So we've used the term employee manual labor,
Yeah.
growers several times, and some of my other delegates, co-delegates, are way more intelligent around this area than I am. But talk to me about the impact to the employees, because a lot of this stuff seems displacing versus additive. How are you guys? You seem like a very conscious company. How is this, the ethical part of like the impact to your employees? Can you talk to us a little bit about that?
So the first thing, it's funny when you go back to technology and how things worked. I'll admit that our growers, when technology first really hit the field, they weren't that in love with it. But they realized that there was a great relationship that can be formed with it because technology allows them to work from anywhere. They now can control their greenhouse from home. They can change the variables. They can do all that stuff from home. So they created that. And what we've did now is we created an environment where they could go home at night. They can do all that stuff. That's all automated. And then you start to look at the people and saying that we're building robots to do picking. Well, we're really not displacing people because there's always other things to be done. And it kind of has just transitioned. So now instead of being a picker, you're now more turning into a gatekeeper type of person, monitoring what the robotics are doing, making sure they're there. We haven't really gotten to that point where we've really said we just need to eliminate a whole factory or a whole shift. I don't really ever hope to see that myself, and I don't think as a company we want to see that either. We want to make sure that we provide a value to it, and there's always a double check that needs to happen. It is food. It is very important to us. There's a lot of hands that need to be checked on this.
Keith, can you tell us a little bit about the model sizes? You mentioned 32 models.
Yep.
Like the number of parameters per model on average, or
I don't know the parameters, but I know the sizes.
Okay.
So they vary anywhere from the smallest one is around 4 gigs, and the largest one is sitting at about 32 gigs.
And can you break down, Keith, what percentage of those are based maybe on the transformer model versus my favorite term, the classical ML models? And then also, second follow-up question, did you bring enough strawberries for everybody?
I'd love to bring strawberries. I would have loved to, but they don't let me. Bringing strawberries from Canada to the States is not an easy task.
Yeah.
It's really not.
Licensing.
It's really, really not. I don't really have a great number. I'd like to say that about 60% of us are more the traditional AI models now, and we're slowly like I said, with our transition more to the Kubernetes, we're trying to start getting rid of those older models that are more just a manual way of doing it.
Homegrown.
Yeah. We're trying to groom them, we're trying to grow it, and we're trying to refine it. That's one of the things I always strive with our team, and it's one of those things that they say. I have 2 sayings I like to say to them. I said, if it was easy, I would have already done it. So I said, you guys, that's what you guys are here for, how to think things. And there's nothing that we can't do better a second time. And our growers live by that too. There's nothing that they can't figure out how to do better on the next crop. And I think that has really made us strive as a company to become better and grow more. So we constantly look at that. We will trial. We have actually, that's one of the perks of being at Nature Fresh. You can actually do a trial. They will put 10 strawberries in front of you and say, which one do you like?
I want that job.
Yeah, I know. There's a waiting list on that one because we're actually trialing and testing it. It's actually 10 different varieties of strawberries, say. Which one lasts longer on the shelf? Which one do you like better? And then us constantly weighing that in our R&D facility. What is the best one to give out there? Because we want a good shelf life, but we want the good taste. And how do we achieve that? And where do we do? And each time we learn, we inference, and we make a little better decision each time.
So we've talked a lot about the kind of the past of what I have 2-part question. One is you mentioned criticality of systems being up. This doesn't seem like a life-saving operation. Why is availability important? And then 2, we haven't really touched on GPUs. Why not GPUs? It doesn't seem like you're opposed to them, but why not GPUs?
Right. So here's the biggest thing is that plant, if you don't irrigate that plant and you let it get too warm, it does damage to the plant. And that doesn't affect today's yield. It affects the yield 6 weeks from now. We get too sunny of a day. We don't close the curtains fast enough. It does damage to the flowers. We could lose a whole growing section of that. So the criticality of our Priva system and our growing system basically that we use is actually so important that an hour or two of downtime is too much. On the wrong day, we could lose a crop with an hour or two of downtime. Because if they don't get irrigated, they don't do stuff like that, it could cost us millions of dollars in damage. So that's why we had to go to the criticality. And then onto the GPUs, we actually, our additional nodes that we did purchase actually have GPUs on them. We haven't enabled them yet because we haven't seen the need for them yet. And we ran into the world of licensing with everything now, where you can't just turn it on in the way we wanted to. So you need to have, for the GPUs we purchase, you need to have a license to properly allocate it to the right way we're doing things. So we're now really debating, okay, we did spend this money on the GPUs and we're not opposed to using them, but what yield will it give us for the cost of the licensing? So is it worth us because we're getting what we wanted out of the CPU factor of it. We're seeing the benefits that we needed to see. So do we just change our approach and just continue to go CPU or GPU? We don't really know yet, but that's where we keep growing and keep changing. And as long as we get the results we need, I don't see us wanting to change what we do. So would I say I'm going to have GPUs on our next generation of nodes? I'll probably say no. For our scale and our size, we're not at that point that we really need it.
So this is kind of anti-intuitive because Ken pointed out that reminder to one of your earlier statements that some of the process is 3.5 hours.
Yeah.
Obviously, a GPU can cut that down to probably 15, 20 minutes. Talk to us about the importance of speed to information versus that balance you're just talking about, licensing costs, et cetera.
Yeah. So there's the thing. So we went from 3.5 hours to 30 minutes. Anything more than that on the CPU level is really just almost overkill because you're just going to be sitting there inferencing a few more times a day. How much are you going to do? We just don't see the value to it at this time to enable that. And maybe one day it'll be, as like I say, I always like to tinker and play with things. Maybe we'll figure out a way to do it. But it's just not there for us. The need wasn't there. And I think that when you get down to that type of inferencing that you're doing it that much, it's almost too much for us. You kind of hit that break point where
there's no return on
there's
value.
no real return on it because you're only comparing data from the last 15 minutes now. And now you're not seeing it. Now at a half hour, you're kind of hitting that because we're looking at our labor and stuff like that and the growing. What's going to change in 15 minutes? Not a lot. So that there is that break-even point in what we want to see and how we want to see it going.
So we can obviously talk about this for hours. Like that, I wish we could have an AI growers day and just talk through it's an amazing use case. But I'm really interested in one other part of it, which is the question I asked Intel earlier, operational ease. You don't have a huge team.
No.
And I can spend, in my small data center, I can spend 40, 60 hours planning an upgrade and needing to move from one platform to another. You have to stay up. And then this inherent value of moving to the next generation processor, we saw the numbers. As you're thinking through your upgrade cycle, how is the partners that you're using, the technology partners you're using, enabling you to, enable your small team to do this and stay focused on what's important?
Yep. So adding nodes is actually very easy for us. We have not a large data center, but large enough we can just add them. Our 2-node expansion basically took us, I'm going to say it probably took the team probably 1 day to deploy. From the time they installed it, they physically put it in, and then we were able to get that compute. But with the model that we've done with our VX Rails and that, where it's expanding, and we can do the preferred nodes from the Broadcom ESX hosts and stuff like that, we can continue just to move those workloads to the needed needed CPUs that it needs to be to get that balance. At the same time, having that breadth of the applications, being able to move across them and still be run on the slower ones, depending on the demand. Depending on what we need to run fast at the time, we shuffle it up, and if we don't need it, we shuffle it down. Growing models at night will get shuffled down. During the day, they get shuffled back up. So it's allowed us to be scalable in a very small size now.
And it's all about automation, right? So you talk a lot about expertise and knowledge. Do you do any data and model sharing with other farmers?
Not really. I'd like to say that there's a lot of still competition between farms because everybody wants to make more product, more things like that. I'd like to say that we like to share the same vendors and the same concepts out there. And I think one of the largest benefits I've ever seen is that a lot of vendors that we work with will help develop things. We get the technology, say, first, get to use it, and then eventually it does hit the other greenhouses. So we're kind of that first one at the envelope doing something, getting the advances, being right on the edge, and then eventually they start selling it to other companies. So a lot of our work does in there, but like I said, my dream is still to see one day farm as a service, where we would just say to the company, here's how to help you grow. This is what you need to put in. Here's your little connection to us, and we will help you grow better.
Right, because to a certain degree, it's modular, right? I mean, the weather is pretty much the same for everybody in the same area, right?
Yeah.
There are benefits where you could box it in and deliver that as a service, right?
Yep.
Like weather model as a service for farmers, for example, right?
And that's what we said.
Right.
We actually had an vision a long time ago about basically doing that kind of concept where we would have one warehouse in the center and lease out multiple greenhouses out to you, and we would provide the growing system.
Right.
We've talked about it. It's always a matter of going from talk to reality and making it happen. And like I said, I think every year we get closer and closer and more reality driven that this is what we need to do. We need to be able to grow more food.
Right, but the reality is if you don't do it, somebody else will do it.
Yeah,
right?
yeah. So that's the thing, and we're working on it. The biggest thing that holds up areas is always infrastructure. And we talk about electric cars, not enough power. Same thing for us. We don't have enough power to our area, so we're pushing governments to get more power for us. We're pushing to get more water. We're pushing to get more wastewater and stuff like that because we don't have enough for the 500 people we employ. So that's sometimes right now the biggest hurdle in the greenhouse industry is getting the infrastructure to the right place to be able to do it. Turning on, 100 acres of lights, that's a lot of power.
So I guess that the AI is also helping you with your ROI, right?
Yeah, it hurts because there is an AI that does some analysis that basically says, here's how much the lights will cost us to run. This is the predicted yield benefit of it. Is it worth it to turn it on? Because some days it's just not there. It's a sunny day, but that's where the great thing with the AI that changes it is that makes a decision on a continual basis. Where you go back 5 years ago, a grower would just make that choice at the beginning of the day. Well, how many times have you said it's going to be sunny all day and then the clouds come in? Well, you got to make that change right away and you don't realize it. And that's where we've always wanted to become that proactive greenhouse. How do we turn it on? Now, lights go into a whole different thing because, like I said, a lot of power in lights, so you can't just flick 100 acres of lights on in one switch to the flick. It takes a little while to happen. So there's a progress to it, but we usually really watch it. And it is neat to see how even from one section to the next, based on where the plants are, they might not have the lights on, even though they're getting the same amount of sunlight because each plant is slightly different. It's at a different stage of its growing cycle, especially the strawberries. They react differently at different times to that light.
So for somebody who literally has a cornfield in my backyard, this has been amazing. I am curious about the efficiency and value prop of investing in the greenhouse model versus the corn yard that's in my backyard. I'd much rather, instead of them develop that for, another distribution warehouse, have a 100-acre greenhouse in my backyard. Has this informed the larger industry on the value of greenhouse versus investing in more traditional methods of farming?
Yeah, I like to think, yes, it's really starting to hit. The biggest thing that changes from traditional to greenhouse farming is how many people have a roadside stand that goes for the, 6, 8 weeks in the summer. We planted our strawberries last June. We started picking them in August, and today we are still picking them, and we will still pick from that same bunch of plants till June of this year when we pull it out. And we're not pulling it out because it's dead. We're more pulling it out because it's hit an age in its life where it's just not growing as optimally as it is. And that's one thing that field farmers usually don't get to do. It's usually a one cut, and there you go. So we do that for everything. We do that for tomatoes, peppers, cucumbers, all that. We'll grow a tomato vine for a year.
You're growing aquaponics, right?
No, we actually we grow for our conventional plants. We ground up coconut husk. It's our natural medium that we do. It's not, so it's similar, but nope, it's not hydroponics in that. There's slightly difference between what we do in hydroponics.
So what would you say to someone who was even maybe not even the same industry, starting out with a project like this and doing something that was like a proactive something? What did you learn along the way? What mistakes did you make, and how would you avoid them?
The biggest thing I'd say is that there is no right way to do it. There is no magical God for AI that's going to make you go down the right path. We've learned more from failures than successes on how to do things. We've learned more how to do it. And the biggest thing to do is to not get stuck in your box. You have to be able to drop back and say, what data do I have? And how can I react to it? And how do I teach that machine language of what it is? So looking at it and saying, this is how to do it. And the analogy I'll use is to find a pest. The easiest way you're saying to find a bug is, well, let's take a picture of it. Well, you can't do it. So we had to take a step back and say, let's look at the data and discover that bug through the data. And that's one of the biggest things I'd say. But again, yeah, I say hiring young, smart kids that right out of university that really want to dig in and are passionate about it makes it a good thing. I like to say that we have a very passionate team for what they do. They love what they do. One of the other lovely sayings I like to say is, if you find a job that you would do for free and can make money from doing it. And that way, you go to work, I'm having fun, I love it. They love being in the greenhouse, they love seeing what they do, and then they love going back to the computer and helping a grower be better.
How many data scientists or machine learning people do you employ? Or
we have 3 of them that are basically I like to say our computer science, our computer side of it. And then they work very, very quickly with our growers, which I like to call grower scientists, to understand, and they kind of help translate. Oh, this is seeing this is seeing that, that's seeing a microfracture, that's seeing things like that. That's what it is, and they define it, and then they help build it out. So we're a very small team, and that's why everything is to scale. We're not that 100 terabyte, huge 100 million terabyte size structure. We're very small, and that's how most greenhouses are.
So Keith, this is Tech Field Day, AI Field Day specifically, and we will keep you up here for the whole day. I'm not exaggerating. We'll keep you up here for the whole day asking you questions, but we do have to move on to the next presentation. I think you're going to join us for the roundtable at 2:30?
Yeah, I will be here for that.
So, all respect to Intel, Kamawaza, Google Cloud, and all those folks. We're going to be interested in their presentations, but I suspect most of the questions will go to you at 2:30. Keith, thank you. I don't usually clap for Tech Field Day presentations, but great job.
Thank you. It was great getting to meet everybody. And like I said, I was amazed at the knowledge that's in here for events like this. So thank you for having me out.
Well, I think we're all amazed at your knowledge and your real world. Let's say it's really earthy. It's really grounded in
very green, very energy green.
No, I have to say, so I have a rule: no applause at Tech Field Day. I also have a rule: no applause at Analyst Day and stuff like that. But my corollary to that is absolutely for guests, guest speakers, people who don't work for the company. 100%. Thank you, Keith. Love that. Thank you for coming and joining us. We're going to take the stream down here for a few minutes, and because we have to stop at every 90 minutes anyway. And we will be back if I'm right on the hour. Is that right, Matt? Rachel and Matt? We're going to be back on the hour. Is it? Okay. Or is it on the 15? It's on the 15. We will be back a quarter before the hour. Thank you, Matt. In 15 minutes. Please do join us. We've got a whole day now of Intel partners talking about how they're using AI, how they're bringing AI to their customers, real world applications. Again, this is all about kind of bursting those bubbles and the ideas that people have about how this stuff works and talking about how it really works. So we'll be back in about 15 minutes. Please come back and we'll see you then.